Hello, everyone. Hello, hello. Uh, Hi. I'd like to introduce the next speaker. I'm very excited about this one because I'm a big fan of his work, and I partially blame him for my addiction because the games that he helps create are super addictive. I don't know if you guys ever played Hades. Yeah. Then you know what I'm talking about. Super addictive and super impressive. So please give it up for Raveen Rajadorai.
Thank you. Hello, everyone. Can you hear me? Yeah, perfect. Um, yeah, today I'm going to talk about, well, Hades. And yeah, I'll start with introducing myself. So, my name is Raveen Rajadorai, but most people know me by Ray. And I started my career primarily in the animation industry. So, I worked on some films such as, TV shows such as like Knights of Sidonia, Ghibli stuff, uh, Star Wars, and shows for Disney and so on. And eventually I moved over to video games. So that's where I started working on a few other titles such as Battleborn, Pokemon, and I moved to working at Creative Assembly, where I worked on the Total War series of games. And most recently, I'm at Supergiant Games right now, and I'm working on Hades, so that's going to be the focus of this talk. So yeah, what I'll do is I'll do a quick introduction to Supergiant Games because I think a lot of you might not know us, maybe, and I'll talk about the pipeline, a bit about the rigging, and um, what we do in the rigs and the features that go into it. So Supergiant Games. So we're a small indie studio, and we're known for games such as Bastion, Transistor, Pyre, and obviously Hades, and now most recently the sequel, Hades 2. We're quite a small studio. Our core team's only about 26 people, which also means that each of our disciplines, because we're so small, like everyone in the art team, for example, is in charge of their own discipline. So I'll show you a bit about the team in a bit. But one of our qualities too is we iterate through production a lot and very quickly. So this talk will kind of go over the decisions we made and also about the pipeline, how it's changed to allow that. And obviously, since we're so small, collaborations at our core, where we have to communicate with each other. We do a lot of design choices. Just not one person. It's a lot of people getting together to talk about it. So yeah, I'll quickly jump to the art team. So we're led by the amazing Gen Z on the art team, and this is our art team basically. So we've got one person, Josh, on VFX and UI. We've got Joanne on environment art. We've got Jeremy on illustration, and that's the 3D team. We've got Morgan on 3D art, texturing. We've got Craig on animation, and that's me on technical art, so handling the rigging, pipeline tools, animation tools, and also in-engine troubleshooting and so forth. So today I'll go over a bit about the pipeline of Hades, not the type that transports oil. And first I'll talk about Hades 1, and we'll go over how it's changed, how Hades 2's pipeline has changed since Hades 1. So a few qualities, like for example, all the animations in Hades 1 were basically just rendered PNG sequences, which has some qualities because it's all pre-rendered. We do have less restrictions on the rigs, but going forward, you can also use any deformers on it. But the big con of this is slow iteration times. So if we take a look at Hades, everything that you see here is 2D. Oh, it's lagging. Yeah, so everything you see here is 2D. Anytime anything changed in the models, that would mean re-rendering the PNG sequences for every animation. And as you can imagine, the iteration times are quite long because anytime we need a change, it's re-rendering everything. And this is Hades for. So looking to the sequel, a few things that we know we needed to do is speed up iteration times, because we were going to have a lot of characters, which means we also needed to be able to iterate on them, change them, add new things without having to re-render whole sequences. So going into Hades 2, although it looks somewhat similar from a 2D aspect, all the characters, everything that you see here, all the characters are all 3D, so we're all running real time in engine, and all the enemies as well. And what this meant is, because it's skeletal animation, we had a lot of benefits, such as being able to do animation blending in the engine, being able to simple things like slow-mos as well. It's quite hard to do when you're pre-rendering a sequence, because if you start to stretch out your animations, your frame rate's going to be affected as well. So now that we're running real time in engine, it's just a lot easier to deal with these kind of things. We can warp animations, make it slower, make it faster. We have the ability to scale even the characters without having to worry about the resolution it was rendered at. And everything was outputted to skeletons and skinning. Now, there are restrictions. I think a lot of you, especially if you work in games, you would understand that when you have skeletons and meshes in game, you do have the restrictions of making sure that everything runs at a proper frame rate. So everything had to be baked down to skinning. Everything had to be on a skeleton, so we couldn't use any deformers that we wanted. And also, one of the things that we did do is we worked on a lot more characters. So if you take a look over here, on Hades 1, we did about 74 rigs for the game. But going into Hades 2 so far, in early access, we've got about 196 rigs. So we've done a lot more rigs, a lot more characters. There's a lot more diversities of characters as well. Some of this includes variants, but these are more or less unique rigs. And I'll go over here to show some animations on some rigs. So you can see over here we have the ability, for example, for the weapon suit to attach everything to the rig. And then we have Hecate over there with some complex animations as well. Now, talk a bit about the rig structure, how we basically changed how we rig. So going into the rig structure over here, we have a clear separation of how we build the rigs. We have layers to them. So we always have a control layer. This is the layer that the animators will control and set keyframes on, etc. And then that connects directly to the rig setup. So this is where all the logic of the rig happens. We usually split it up based off a local setup and a world setup, so we can localize some deformations. And then you have a world setup. And then we have this other layer, which is the base skeleton. Now, this is meant to basically take in the transformations and everything from the rig logic and put it onto a skeleton. And going into the export skeleton, this is what actually gets exported to the game. This is just purely skeletons and meshes. We use direct connections, so it's a simplified setup as well. And one of the benefits of this is if we wanted to swap out a different type of rig, we would just basically break the connections, swap out to type B, for example, and connect it back to the export skeleton. So we're preserving the skeleton that's already in game, and we're also preserving the animations that we potentially have. And now I'll move on to to fit rigs. So we have this concept of fit rigs where when we build a rig, the traditional way is you have an auto rigger and you have a build step. But something that we do in on Hades 2 is we have this concept of fit rigs where basically you can almost think of it as pre-built rigs that we fit to the characters. So this allows us to do basically drop in, fit it to the character that we want. There's no builds, so it's quite quick to do. And then we layer custom rig setups on top of it. And fit rigs are just Maya files, so we just literally drop them in and connect them up to whatever we need to. I'll show a little example of what it looks like here. So for example, if we had a fit rig for this biped, we would drop it in, and using the fit rig points, we would position the skeleton. And while we're doing this, this is updating the rig logic in real time as well, so that we're kind of avoiding the build step in a way. So you can kind of see we're fitting it over here. It's the character. Now, there are some benefits to doing it this way, which is it's quick. It's easy to just drop in these rig components and rig modules and add it to the characters. And at the same time, it's quite, it's less time consuming than going through a build step as well. So you can kind of see here, we'll fit the arm now. So all these are just basically points, and we're just fitting the points there. And as you do this, you can see that the rig logic is also updating. So towards the end of this, you'll see that you can just pick up the rig and just start using it. And now this step doesn't mean we don't have a build step. I'll talk a bit about that in the next slide. But it does allow us to, once we're happy with a module, it's to compartmentalize it into a fit rig module, and then we can reuse that. So yeah, so here we've kind of fitted it, and you can grab the controls, and now everything just works as it should. So we still have a build step, and the build step is something we usually do early on. So in our case, we use the base skeleton as the core guide, and we build our rigs from there. So it's a very quick blurb of some of the calls. You know, for example, this is a little rigging API we have. It will create a controller structure. It'll create the control modules. And once we're happy with all of this, we basically turn this into a fit rig. Couple of other characters and some animations you can see. So some of the rigs morph into different shapes. So all of this is happening on a skeleton level because that's all we can use. We do corrective shapes as well. So for example, keeping the volume of the neck over there. We also use correctives for the usual spots such as shoulders, and elbows, knees, etc. And twist joints as well. So you can kind of see it. So again, all of this is happening on a joint level. Couple more pictures, different characters. I have a fancy pointer, if you can see it. But you can see we have like different types of rigs, different versions to solve. But most of these base rigs are done using the fit rigs. So we have, the base biped, and most of them reuse the same base biped. We might make tweaks here and there, but it makes it a lot quicker. So with such a small team, we've been able to build so many rigs so quickly while iterating through production as well. There are advantages as well to reusing a similar base structure, which is you can copy animations over. So as you can see in this slide, here's Kronos running like Mel. Obviously, we didn't use this in the game, so but it's really nice for testing because you can, you can just drop in any animations and test it out. Now we'll take a look a little about performance, because one of the core things when you're dealing with rigs is obviously when an animator is working on your rig, you don't want it to be slow. You want it to have enough performance so you don't have to play blast it every time you want to look at an animation. So when we built the rigs, we always kept that in mind to keep a decent frame rate, to make sure that the rigs, evaluate properly on the evaluation graph, and also taking into account that it would use the GPU for the mesh deformers as well. So over here you can kind of see an example of Mel's rig. I've zoomed into the profile graph. So what you're seeing here is basically how long each node in the graph or in the rig takes to evaluate. So overall, it takes about 4.4 milliseconds per frame, which, although, as you can see, there are areas that can be improved quite a bit. It's more than enough for what we needed and for the animators to work in a comfortable way. So look at another character. There's some that are a little heavier. So for example, this character, a little more to the rig, takes a little longer to evaluate, but still 5.7 milliseconds is a very decent frame rate to work with. Can be improved. And then going to Kronos, he has a lot more to him. He has also the setup that morphs into different shapes. So his scythe can become his walking stick, and his wings can become his cloak. So there's a lot of extra stuff to set up over there. So for him, it took about 8 milliseconds, which is still really good. And now I'll move on to some rig features, like things we put in the rigs that I thought were kind of interesting to take a look at. So for example, we do something called dynamic rigs, where we have controllers. Say in the traditional sense, you'll have a controller, you move a controller, it moves a part of the body or moves a part of the rig. But we also have an ability to change how much that's affecting the rig dynamically. So for example, over here, we can take a look at a little video for that. So this little character over here, you can see you're moving the rig, but you can also change how much it influences the rig as well. So this allows the animator to do things such as, I need a larger motion for this animation, or if I need a small animation. So similar things over here. And then we do limit it so that it doesn't break the rig too much. Yeah, and we'll take a look at another one over here. So for example, for this character's hair, little controller to move everything around, but you also have the ability to change how much of the head influences as well. So over there, we've limited it so it doesn't break the heads. So yeah, see, it does allow for a lot of interesting things and gives the animator a bit more control over if they want to control a small area or larger area. One important thing about this setup is because we're working on a game engine, we need to make sure that anything that we do in this sense with dynamic rigs, it needs to transfer over to the skeleton. So everything that we've done is always affecting the skeleton as well. Let's see if that plays. There we go. So as you can see, even though it's a dynamic rig, it'll affect the skeleton in a way it should. It's lagging a bit there. Let me just go back, and I'll go back to that video. Yeah. Paused. And some of the other features that we implement is we use procedural animation quite a bit. So procedural animation is basically having animation generation within the rigs itself. So this is just purely for giving a base animation to the characters. It doesn't mean that it takes work away from the animators, but it kind of gives them something to work from. And it uses, I'll talk about Bifrost a bit in a later slide, but basically we use Bifrost to do a lot of these animations. So for example, this character, we have procedural animations to do the wiggles on the tail, for example. We have different layers to the procedural animation, so you can add variety to everything. And obviously this is driving the controllers, so the animator can go on and add more to it if they wanted to. Yeah. And we'll take a look at another one. So something that we also have to keep in mind with these procedural animation setups is basically, because we're working in games, you're always going to have to keep a cycle, because you're going to create a cycle of animation, drop it into the game. So when we build these procedural animation controls, we always have to give the ability to make sure that you can form a full cycle. So in the end, for example, here, it'll always form a full cycle based off the wavelength. So if the wavelength is 2, every 2 units, it'll form a cycle. So that way you can always form a cycle during your animations as well. And when I say cycle, I mean starting on the same frame and ending on the same frame. And here's another character with more procedural animation to it. So almost all of this is procedural animation. So generated in the rig. It's a little, I don't know if anyone's played Half-Life 2, but kind of reminds me of the head crabs. Or whatever that comes from the ceiling. So as you can see, we've got procedural animation for the mouth, for the little top area as well. It's all being generated. Each tentacle has its control for procedural animation as well. So you can add variations to it if you need it. It really helps with just giving some base movement, even though if we just needed something to just be alive a little bit without having to do too much work, this helps a lot. So as you can see with Charybdis. And next, to tie into procedural animation, we use Bifrost quite a bit for procedural animation. And Bifrost is basically, it ships with Maya. It's a visual programming system. And what you can do is you can create little custom nodes within the scene that you use within your rigs or whatever you need to. So for example, we use it in most of the procedural animation setups, but we also do use it for some custom nodes on the rig itself for stretching, squashing, etc. And it kind of looks like this, roughly. So this is a very simple graph where you can kind of see it's just generating sine waves. It's some randomness to the sine waves, and it outputs rotations that you can connect back to your rig. Here's another one as well. So there's just different types of animation. So sometimes we have more complicated animation for some characters, but other times we have less to put into it. So yeah. And it gives us a lot of control because all of this is stored within the scene. So we don't have to, if we are sending it to the animators or anyone, we don't have to send a custom node, get them to load up custom tools. It all just loads up with the scene. An added benefit of Bifrost is you can draw in the scene with it. So we do use it sometimes to get little fancy looking UIs. So well, this is a little simple rig, but once we get to the point where we tweak the procedural controls, you'll notice those lines will update based off what the animation looks like. So as you can see there, so it gives the animator a little preview of, okay, this is what the procedural animation is going to do. And you have a rough idea of like the movement you can expect. It's the same for the top over there. It runs relatively quick. We haven't noticed much slowdowns, but obviously in this case, we're only drawing 2. So it's quite straightforward. And this is what the graph looks like for it. So essentially what we're doing is we're taking in the information of the procedural animation, we're converting it to strands, and we're outputting that into the viewport as a strand. I've got a couple more videos over here. So let's take a look. So as you can see, some of the characters we have, we build the rigs for the weapons, for the instruments. Yeah, some really cool animations. A bit of Skilla over here. Has anyone played the Skilla Hades 2 yet? Yeah? Have you got to Skilla yet? Yeah. So even the rigs over there, you can kind of see that we built the rigs so now that you can squash into the clamshell. So they're quite dynamic as well that way. She too has a lot of the dynamic set up on her hair so that you can control how much of her hair moves. And a couple more characters here. If she was a real cat, she'd follow this pointer. Yeah, and yeah, a few more characters, and again, as you can see, we've got a large variety of characters. Some are, some have these, the goat legs, and some have, little noodle legs. But so far, our rigging system and our rigging processes have helped a lot this way, where we can basically just generate rigs really quickly. They structurally and functionally quite simple rigs, but they also allow us to iterate very quickly on the animations. A few more rigs here. We've got some crazy characters. I'm sure if you've played Hades 2, you've probably run into some of these characters already. And let's take a look at a couple more. So Cerberus has a lot to him. As you can see, there's a lot of controllers on him. But yeah, again, a lot of the things on his arms, for example, use a lot of the procedural animation. We use procedural animation for some of his ears as well, I think. And yeah, it just gives the animator the ability to add a little bit of life to the characters very quickly. And yeah, I think I probably spoke quicker than I practiced, so we're coming up to the end. Does anyone have any questions?
Hi.
Hello.
Firstly, thanks for the presentation. I'm a big fan of Hades. Still haven't had the time to play Hades 2, but I'm a big fan of the first one, so it was awesome to see this. I was curious if there were any downsides to the change that you've made from Hades 1 to Hades 2, from pre-rendered to real-time render.
So one of the biggest changes were in pre-rendered. Like when you pre-render, you can kind of use any deformer. You can kind of do anything you want in the scene. So you were able to cheat a bit more in the scenes. So for example, you could use a deformer that was, tearing a character apart, and you didn't have to worry too much about it. You could just pre-render it, becomes an image, so there's no problems. But when you go into when we moved into like using skeletons and in working in the engine, now we have the limitation of using only skinning and only joints. So whenever we needed to do anything creative, like or rather anything crazy where we had to kind of tear stuff around or do things that are not very skinning friendly, then we would have to build a rig where it would all bake down to skeleton. So for example, when we looked at Kronos's staff earlier, so if that was pre-rendered, we could just use a blend shape very easily, morph it into a walking cane into a scythe. But what we did is basically we baked down the deformation of the blend shape for that. So we did have a blend shape, but we baked it down to the skeleton level using smooth skinning decomposition. And yeah, that was basically taken into the engine then.
And then, were there any like problems with the performance because of the change?
Yeah, so there are limitations when you are using skeletons and meshes. You kind of need to make sure you can't go above a certain amount of joints. You can't go above a certain amount of skinning influences. Otherwise, you're going to start affecting frame rates and everything. So we do have limitations that way where there's a set limit. And usually what we do is, which goes back to the collaboration step, where if we find something that's not working quite within the restrictions, then we maybe try to change the design scope differently and basically make decisions to make it work under the restrictions that we have.
Thanks.
No worries. And I Really?
Hi, it was a great presentation. I wanted to ask you, who's your most favorite god in Hades?
Most favorite god? That difficult choice. There's so many. I love, honestly, I love all the designs, so it's very hard to pick one. But maybe Athena, I guess. Yeah. I would say, yeah, because she's got amazing designs as well. Yeah.
Okay, so hello. So happy to see you there. It's gonna be like continuation to the question of my colleague. If there was, if you have a favorite model who you were working at, and if you have a favorite or the most difficult for you, why it was?
That's a good question. There are a few. So there are characters that we've done that are probably not seen yet. So there's some that have been tougher to do. So a lot more. Basically, there's a lot more to the rigs, and due to the restrictions, that's always been the difficult thing, to fit everything within the restrictions. So I wouldn't say I've shown anything specific, maybe out of here. Cerberus was a challenge because he was so big on screen and he has a lot of different heads and everything. But yeah, there were a few that were challenging, but it's not shown here. But yeah, I would say just fitting it within the restrictions and making sure it works with skinning and everything. That was always the challenge. Actually, on that note, Kronos was initially a challenge because it was something that was very different that we did, where he needed to morph into something. His wings are also morphing. So that was a change compared to the other characters, basically. So yeah, I would say he's, at least here, he's probably one of the harder ones.
All right. Hi. Thank you so much for your presentation. I was wondering how much of what you achieved is due to like built-in tools into the software you use, and how much of it is custom scripts that you had to implement yourself?
So when building the system, usually as a technical artist, you would be building a lot of tools in a pipeline. So we do build a lot of custom tools for the art pipeline. But one thing about the rigging setup is when I was building it, I wanted to make sure that we didn't use too many custom plugins. because I didn't want to go down the path of maintaining plugins through different versions and, go down the years and then something wouldn't work because I need to recompile it. So a lot of the rigs are using just vanilla Maya nodes, and anything that needed something custom would fit into the Bifrost thing that we talked about, where we just create something there. And the nice thing about it is Bifrost ships with Maya, so you could just still load up the scene and use it.
Hello. Thank you very much for the presentation. Do I understand it correctly that each of these almost 200 rigs uses its own animation set? So how big are these sets? How many animations you have per rig?
We have a lot of animations in game. Basically, most of them have their own unique animation sets. There might be a couple of variants that kind of reuse it, but last I checked, we had at least, as far as animation clips in game, we probably had over 4,000. So there is a lot of animations.
So there would be like 200 per rig?
Yeah, for roughly the 200 characters. Some use more, like obviously Mel. I would say Mel has the most animations because she's the player character. So we have a lot of animations for the leans and everything. So yeah, we do have a lot of animations. And in Hades 1, there was a lot of animations as well, which was where the pain point came of if something changed, you would have to re-render the whole animation set.
Yeah. Thank you very much.
Hi again. Thank you for your lecture.
Don't worry.
Thank you for coming here. I have a question. How many issues are there when 3D artist is creating a 3D model, and how often do you have to send it back for him to like redo the retopology because it just doesn't work well with the faces or something?
To be honest, on this project, not too much because our team is so small. So Morgan, she's absolutely amazing at what she does. So when we first started the project, the animators, myself, and also Morgan, we all sat down together, talked about what we wanted to do for all the characters. So we tried to set up documentation for basically this is how we would like the topology to be for the characters. This is where we need stuff. So. And then we tend to have little kickoffs as well to basically say, oh, I think this character is going to need topology over here. So because of the collaboration standpoint, we haven't had the thing of, oh, this is not working, send it back. I'm having a hard time actually thinking of an occasion that happened. It might have happened once or twice, but yeah, I mean, it's very minimal.
Hi, so in Hades 1, you said all the animations were re-rendered if anything changed. But what about, for example, the weapons? So were the weapons like rendered separately or with the character?
Sorry, I didn't quite get that.
The weapons. So
Oh, the weapons.
yeah.
So those were rendered together with the characters, so that would be part of it as well. So it's a new set of animations. Yeah, and that was an issue. I think our graphics programmer did a talk as well, talking about some of the issues with, re-rendering everything together. And also one of the major issues is shadows. You can't really get proper shadows because it's 2D, so it's just going to layer on top of everything. So yeah, everything kind of had to be rendered separately like that.
Yeah, the previous question kind of gave me an idea for another one. How did you manage to make shadows in Hades 1?
So I think when our graphics programmer got asked this question, his answer was, we didn't. Because it was an issue. It was basically an issue where it was rendered with the image, and it would just layer over everything really, because it's just a 2D image. Yeah. Though we don't have that problem anymore because we're 3D now.
Hello, thanks for the presentation. I wanted to ask about the procedural animation you showed earlier. You use the Unity game engine for the game, or
No, so we have a proprietary engine.
okay?
Yeah. So
Do you control the procedural animation only on the animation software side and then make it and play it in the engine, or do you actually control the procedural animation in real time in the gameplay?
so it's baked down from the animation software. So we do have a very quick pipeline, so we can update the animations very quickly and just goes into the engine. It also has hot reloading, so if we update the animation straight away there, so it doesn't run in real time. Yeah.
Hello. Thank you for the great presentation. Did you run into any issues with the number of skeletons when having like active skeletons on the scene, where you're limited, like you can only have so many numbers of different skeletons in per scene?
Yeah, so when you look at the scene, we do have like a general budget for how many joints and how much skinning can be shown on the screen at the same time. So a lot of the decisions we make for fights and everything is based off that budget as well. So we do set a budget, and then we try to build the rig in a way that would fit within that budget as well, so that, you know, we can, if we needed 50 characters on the screen, we would make sure that the skeletons for this were very simple so that we could put 50 characters on screen. Yeah. Yeah, I hope that answers that. Yeah, definitely. Cool. Any other questions? Cool. Yeah, cool. Thank you so much for coming. Yeah.